Welcome, dear learners, to the next edition of Arithmetic Progression from Mathlete Minds. Arithmetic progression always reiterates that decisions taken with precision lead to the success of the mission. So let us see how precisely and decisively we can solve numericals of arithmetic progression. The first question to begin with is: in a school, the students plant saplings around the school to reduce air pollution. It was decided that the number of saplings each section of each class will plant will be double of the class in which they are studying. If there are 1 to 12 classes in the school and each class has two sections, then find how many saplings were planted by the students. So we have initially classes ranging from class 1 to class 12. And there are two sections in every class. That is, class 1 has two sections, class 2 has two sections, class 12 has two sections. All the classes have two sections each. Now, according to the condition of the question, the saplings that has to be planted will depend on the class in which the students are studying. For example, each section of class 1 will plant two plants each because it is double the number of the class in which they are studying. Section B will also plant two plants. Class 2, each section will plant four plants. Similarly, B will also plant four plants. Uh, Class 12, each section will plant 24 saplings, and B will also plant 24 saplings. So on the whole, when we take the number of saplings from class 1, it is 4. From class 2, it is 8. And it goes on this way. And class 12, we have 48 saplings. So the total number of saplings that needs to be planted will be S12 is equal to 12 by 2. 4 plus 48. I'm using here the formula Sn is equal to n by 2, a plus l. Because we know the value of a, we know the value of the last term l, and we even know the number of terms. So this becomes 6 into 52. That is equal to 12, and this is 312. So the number of saplings planted by all the children of the school are 312. Moving on to the next question, we have two cars starting together in the same direction from the same place. The first moves with a uniform speed of 10 km in 1 hour, while the second moves at the rate of 8 km in the first hour, thereby increasing its speed by half kilometer every hour. After how many hours will the second car overtake the first one if both cars go non-stop towards their destination? So we have here two cars racing towards the destination. Initially, the first car starts and maintains a uniform speed of 10 km per hour. That means throughout its journey, it will not budge from 10 km per hour speed. The second car, car B, starts at a speed of 8 km per hour, but it goes on uniformly increasing its speed every hour. In the second hour, the speed of the car B becomes 8.5 km per hour. Third hour, it becomes 9 km per hour, and so on until it overtakes the car A. So now let us take the distance traveled by car A in t hours when the second car B overtakes the first car. So car A in that t hours will travel distance speed into time, that is 10 km per hour multiplied by t hours, that will give you 10t kilometers. So car A has traveled 10t kilometers when the second car overtakes the first one. Car B in this time period must have traveled t by 2, 2 into 8 plus t minus 1 into half. We have this arithmetic progression of a of its speed. So the distance traveled will be t by 2, 2 into 8 plus t minus 1 into half. Now on simplifying this, taking the LCM, we can take out 4. This becomes 4. I have taken the LCM here. So this becomes 32 plus t minus 1. So this can be written as t by 4, 31 plus t. Now this is equal to 10t because the first car has been overtaken at this t hours. So t by 4 is into 31 plus t is equal to 10t. On cross multiplying, we get here 31t plus t square is equal to 40t. So this becomes t square minus 9t is equal to 0. So t can be taken out as common. T minus 9 is equal to 0. It's a quadratic, so obviously we'll get two solutions. One will be t is 0, one will be t is equal to 9. Now, of course, we cannot take 0 hours, so the time in which the second car overtakes the first one will be 9 hours. The next one is 150 workers were engaged to complete a piece of work in a certain number of days. 4 workers dropped the second day, 4 more dropped on the third day, and so on. It takes 8 more days to complete the piece of work. Find how many days it took to complete the piece of work. So supposing, let us take initially on the first day, 150 workers went to do the work. Second day, there were 4 workers who dropped out, so 146 workers. Third day, it was 142, and this way, 4 workers were dropping each day. Now here it's mentioned it takes 8 more days to complete the piece of work. So let us take n days if the workers are dropping sequentially in numbers of 4. N days to be taken by the entire number of workers to complete the piece of work. So this becomes, if we take out the value of this summation over here, this Sn will be equal to n by 2, 2 into 150 plus n minus 1 into minus 4. So this becomes equal to, we can take, remove 2 from this over here and we can get here n into 150 minus the 2n plus 2 over here. So this becomes n into 152 minus 2n. Now, if we take the number of workers working 150 all the time, in that case, they will complete the work in here it is 8 more days if they are dropping. So I have assumed n days when they are dropping. So obviously, if all the workers are working together, the work will get finished in n minus 8. So this is the work done when all the workers are working together. This is the time and this is the number of workers. So both of them will be equal. So equating the two, 152n minus 2n square is equal to total work done over here is 150n minus 8 into 150, that is equal to 1200. So now this becomes, if we simplify this further, 2n square minus 2n minus 1200 is equal to 0. Taking out 2 common, n square minus n minus 600 is equal to 0. So n square minus n minus 600 is equal to 0. We can factorize it by any method that suits us. So 600, we can take the factors here as n square minus 25n plus 24n minus 600 is equal to 0. So this becomes n minus 25 plus 24 n minus 25 is equal to 0. So n minus 25 is one linear factor, n plus 24 is another linear factor. Now obviously n will be equal to 25 days, n is equal to negative 24 cannot be accepted. Number of days can't be negative over here. So this sum can also be worked out by assuming that initially the number of workers for this 150 workers when they are working together, they take n days and here it can be taken as n plus 8 days. That way also it can be solved. The next question is 200 logs are stacked in a manner such that 20 logs are in the bottom row, 19 in the next row, 18 in the row next to it, and so on. And how many rows are the logs stacked and how many logs are there in the top row? So in the bottom row over here we have 20 logs, then it goes on decreasing by 1 each. But there are altogether 200 logs. So to find out the number of rows over here, let the number of rows be n. So this will be n by 2. 2 into 20, bottom row has got 20 logs plus n minus 1 into the difference over here, common difference will be minus 1 because the sequence will be 20, 19, 18 and so on. So the common difference is minus 1. So cross multiplying this, we get here 400 is equal to, open up the bracket, so you get your 40n and this will be minus n into n, that is minus n square, and plus 1 into n, that is equal to plus n. So this on further simplification gives us n square minus 41n plus 400 is equal to 0. Now again this needs to be factorized. You can do the factorization anyway. Now 400 factors of 400 can be taken as 25n and plus 16 minus 16n plus 400 is equal to 0. This is minus negative here. So this becomes n minus 25 minus 16 into n minus 25 is equal to 0. So we get here two linear factors, n minus 25 and n minus 16. Now out of these two factors, we get one solution of n as 25, the other solution as 16. Now both the solutions may not be correct, they may be correct, so let us check it out. So if we find the value of A25, that is the number of logs in the 25th row over here, that will be equal to 20 plus 24 into minus 1. So this becomes 20 minus 24, that is minus 4. And if we take A16, this becomes 20 plus 15 into minus 1. That means this is 20 minus 15, that is equal to 5. So if we take 25 rows over here, in the 25th row on the top we have negative 4 logs, which is not possible. But if we take only 16 rows, then on the topmost row there are 5 logs. So number of rows will be 16 over here, and the topmost row will have 5 logs. The houses of a row are numbered consecutively from 1 to 49. Show that there is a value of x such that the sum of the numbers of the houses preceding the house number x is equal to the sum of the number of houses following it. Find this value of x. So we have here houses numbered from 1 to 49. In between them, there is a particular house number which is named as house number x. Now, according to the question, the sum of the house numbers preceding this x will be equal to the sum of the house numbers succeeding x. So the preceding number over here will obviously be x minus 1 and the succeeding one will be x plus 1. So sum of the house numbers from 1 to x minus 1 using the formula will be sx minus 1 will be equal to x minus 1 by 2. A is 1 and last term is x minus 1. So this becomes x into x minus 1 by 2. Now for the number of houses after x, the sum of this can be obtained by taking all the houses, sum of all the house numbers, and from that subtracting the summation of x house numbers. So this will be equal to S49 minus Sx. And this obviously is equal to sum of the houses preceding x. So that means this is equal to Sx minus 1. Now S49, what is S49 equal to? 49 by 2, 1 plus 49. Using the formula n by 2, a plus x. And this is Sx, that is equal to x by 2. And this first number is 1, 1 plus x. And this is of course x by 2 into x minus 1. Now this becomes 49 into 50 by 2, that is 49 into 25. And take the x terms to the same side, this becomes equal to, take out x by 2 common, so we are left with x minus 1 plus x plus 1. So this plus 1 and minus 1 get cancelled and we are left with 49 into 25 is equal to x by 2 into 2x. 2 and 2 get cancelled. So this is equal to 49 into 25 is equal to x squared. So x is equal to square root of 49 into 25, which implies x is equal to 7 into 5, that is 35. So we have this house number 35 over here. It is such that if we add the number of houses preceding house number 35, that will be equal to sum of house numbers after 35, that is 36 to 49. A ladder has rungs 25 cm apart. The rungs decrease uniformly in length from 45 cm at the bottom to 25 cm at the top. If the top and bottom rungs are 2.5 meters apart, then what is the length of the wood required for the rungs? That means we have to find the total length of the wood required for all these rungs. Now, there is something very important to be understood over here. The total distance between the bottom rung and the top rung is 2.5 meters. 2.5 meters, that means equal to 250 centimeters. In between any two rungs, there is a gap of 25 centimeters. So 250 divided by 25 will give us 10 rungs. But in reality, there will always be one rung more. So the total number of rungs will be 11 rungs in the ladder. Because let's take an example to understand this. Supposing the distance, vertical distance is 100 and we have to place 100 centimeters, and after every 20 centimeter we are positioning the rungs. So one will be over here, the second one after 20 centimeters will be here, the third one after 20 will be here, and then the fourth one after 20, then the fifth one, and then the sixth one. So altogether the number of rungs will be 6. Similarly here there will be 11 rungs in this particular ladder. So the length of the foot will be S11 is equal to 11 by 2. The first rung has the measurement of 45 and the last one has 25 centimeters. So this becomes 11 by 2 into 70. That is equal to 11 into 35. That is equal to 385 centimeters, which is equal to 3.85 meters. Next one is, a man arranges to pay a debt of rupees 3,640 annual installments which form an arithmetic progression. He dies after paying 30 installments, leaving one-third of the debt unpaid. What was the value of the first installment? So total amount of money that he has to pay is 3,600. He pays this in 40 annual installments. So let us see how we can frame a relationship between the first term and the common difference. So 40 by 2, 2a plus 39 into d, using the formula n by 2a plus n minus 1 into d. So this can be, this becomes 20, this 0 gets cancelled and 2. So we are left with 180 is equal to 2a plus 39d. We get one equation. Now he pays 30 installments and he dies. So, but one-third of the debt is unpaid. So what is the debt paid? That is 2/3 of 3600, which is equal to 2400. That means we can frame another equation. 2400 has been paid in 30 installments, so 30 by 2, 2a plus 29 into d. So this becomes 15, and this is 15 ones 15, 9, so we get here 160. So 160 is equal to 2a plus 29d. So we get another relation over here. With the help of these two, 180 is equal to 2a plus 39d, and 160 is equal to 2a plus 29d. After solving these two equations by any method that suits you, we get here by using elimination method. This is 20 is equal to 10d. So d is equal to 2. So now a can be obtained by putting the value of d in any one of these equations. So we get here 160 minus 29 into 2 is equal to 2a. So 160 minus 58 is equal to 2a. That is 102 is 2a. So the first installment A is equal to 51 rupees. So A is 51. That is the first. What was the value of the first installment? That is 51 rupees. The ratio of the sums of m and n terms of an AP is n square is to n square. Show that the ratio of the mth and nth terms is 2n minus 1 is to 2n minus 1. So here we have Sm by Sn is equal to m square by n square. Now Sm can be written as m by 2, 2a plus n minus 1 into d. And Sn can be written as n by 2, 2a plus n minus 1 into d. This is equal to m square by n square. So this 2 and this 2 gets cancelled. One n gets cancelled from here. One n gets cancelled from here. Cross multiplying these two, this proportion. So we get here 2an plus nd into m minus 1 is equal to 2am plus md n minus 1. Now transferring these terms together, 2a n minus m is equal to, taking this to the right hand side, we are left with taking our d common, mn minus m, and this will become minus nm plus n. So this gets cancelled. Now 2a into n minus m is equal to d into n minus m. So from here we can say that 2a is equal to d. This implies 2a is equal to d. Now the ratio of the mth and nth terms, that is am by an, we need to find that out. So am can be written as a plus n minus 1 into d, and an can be written as a plus n minus 1 into d. D is equal to 2a from the previous part of the question solution, so we can replace it, a plus n minus 1 into 2a, and this becomes a plus n minus 1 into 2a. Taking out a common, we are left with 1 plus 2m minus 2, and denominator 1 plus 2n minus 2. So a and a will get cancelled, so numerator will be 2m minus 1 and denominator 2n minus 1. So this is the ratio of the mth to the nth terms. That is what we were supposed to prove. So with that we come to the end of this video. Thank you for watching. Kindly like and subscribe the channel.